We have an element of material which is subjected to the given state of stress. In part A, our goal is to determine the principal normal stresses and principal shear stresses. To find these principal stresses, we will use the equation which says that the determinant of the matrix A will be equal to 0, which is equal to sigma cube minus I1 times sigma square plus I2 times sigma minus I3. We know that I1 is equal to sigma x plus sigma y plus sigma z. I2 is equal to sigma x times sigma y plus sigma y times sigma z plus sigma x times sigma z minus tau xy square minus tau yz square minus tau xz square. And finally, I3 is equal to sigma x times sigma y times sigma z plus 2 times tau xy times tau yz times tau xz minus sigma x times tau yz square minus tau y sigma y times tau z x square minus sigma z times tau y x square. When we substitute the given stresses in these equations, we will obtain I1 is equal to minus 40 plus 100 plus 30, which is equal to 90. I2 will be equal to minus 40 times 100 plus 100 times 30 plus minus 40 times 30 minus 50 square minus 12 square minus 0, and it is equal to minus 4,844. And finally, I3 will be equal to minus 40 times 100 times 30 plus 0 minus 40 times 12 square minus 0 minus 30 times minus 50 square. And it is equal to minus 189,240. So we will solve the equation sigma cube minus 90 sigma square minus 4,844 sigma plus 189,240 is equal to 0. And when we solve the equation, we will obtain sigma 1 is approximately 117.52 MPa. Sigma 2 will be approximately 28.66 MPa. And sigma 3 will be minus 56.18 MPa. Since we find the principal normal stresses, we can now find the principal shear stresses. This was part A. For part B, we know that tau 1 will be equal to sigma 2 minus sigma 3 over 2, and it is 42.42 MPa. Tau 2 will be equal to sigma 1 minus sigma 3 over 2, and it is 86.85 MPa. And finally, tau 3 will be equal to sigma 1 minus sigma 2 over 2, and it is 44.43 MPa. Now we can move to part C. Now our goal is to find the direction cosines for each principal normal stress axis. Let's start with sigma 1. For sigma 1 is equal to 117.52 MPa, our matrix will look like minus 40 minus 117.52, minus 50, 0, minus 50, 100 minus 117.52, 12, 0, 12, 30 minus 117.52. And we will multiply this matrix with another matrix, which is L1, M1, N1. And these are the direction cosines for the first principal normal stress. And the result will be 0. So, when we write the equation system, we will see that 157.52 L1 minus 50 M1 will be 0, minus 50 L1 minus 17.52 M1 plus 12 N1 is 0, and finally 12 M1 minus 87.52 N1 will also be 0. And don't forget that L square plus M square plus N square will be equal to 1. This is important. So when we solve this system, we will obtain L1 is equal to minus 0.3, M1 is equal to 0.9451, and finally M1 will be 0.1296. We will follow the same procedure for sigma 2 and sigma 1. For sigma 2, L2 will be equal to 0.0803, M2 will be equal to minus 0.1103, and N2 will be equal to 0.9906. And finally, sigma 3 will be equal to minus 56.18 MPa, and it will give L3 as 0.9506, M3 as 0.3076, and 3 will be minus 0.0428. By the way, sorry, this is not part B. This is a part of part A. So let's write part B also. We can say that the maximum normal stress will be equal to sigma 1 because it is the largest one, and its value is 117.52 MPa, and the tau max will be equal to tau 2, and its value is 86.85 MPa.